Hello everyone, this is lesson 10 from unit 11. The last one I'll do in this unit. Kirk will do the lesson 11. The last one is tan, the tangent portion of the trigonometric trio, because we've already talked about sine and cosine, SOHCAHTOA. TOA. So a right triangle trig definition of tangent, this is just your TOA. Tangent equals opposite over adjacent. You've seen it before. Just some special right triangles here. If you want to find a missing side, which I'll label as X, that is a special 3, 4, 5 triangle. So that X side equals 3. And that's one that you should recognize, you should know. If not, you can always use the Pythagorean theorem. So if we want to find the sine, cosine, and tangent, so sine of theta, which is which is opposite over hypotenuse. Cosine of theta is ca, which is 4 over 5. And tan of theta is toa, which is 3 over 4. SOHCAHTOA. Okay? You should have learned that probably, and I think you were introduced to it in 8th grade. And then you saw it again in Algebra 1 and Geometry. So when we have something like in letter B, a little more difficult, this would be 2 squared equals 1 squared plus, we'll call this side y this time, y squared. So you have 4 equals 1 plus y squared. 3 equals y squared, and then it's a square root plus or minus square root of 3, depending on what quadrant you're in. Remember the bow tie. So this is root 3. So I'm just going to say S for sine. Here's your theta. So, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tan, which is TOA, opposite over adjacent, which is root 3 over 1, which is just root 3. Now, when we're talking about the unit circle, we can follow the same exact trig definition that you've already been taught. It is still TOA. It is still tan equals opposite over adjacent. But since we're talking about an ordered pair in the unit circle, theta, remember, is always at the origin. So we have the tan equals opposite, which is y over x. And in the second part it says, given how we define sine and cosine, how can we define tangent in terms of sine and cosine? Well, if we take tan of theta, I forgot the theta in there, is y over x. Remember, an ordered pair, this is cosine, this is sine. So this equals sine over cosine, both with a theta. And that is a very important trig identity that you will use in future math classes. And it is on the top of the next page as well. So that is your definition of tangent in terms of sine and cosine. Now, what I'd also like you to write on your paper and try to remember we did the sine and cosine, the 30, 45, 60, 1, 2, 3, 3, 2, 1. Well, tan is the third one that you want to try to memorize. Okay, so we have tan, so we have 30, 45, and 60. And again, these come from those triangles. So the tan is root 3 over 3 of 30. Tan of 45 is 1. Tan of 60 is root 3. So the tan of 30 is root 3 over 3. Tan of 45 is 1. Tan of 60 is root 3. Be nice to have those memorized, because then you don't have to worry about doing all of this with tan equals sine over cosine or trying to create a triangle. So using the unit circle, and those all based on the unit circle, definition of tangents, and we're just going to use this up above. So tan 60, what you always ask is what quadrant, so it's in quadrant 1, therefore tan is positive. Tan of 60 is just root 3. Otherwise, if you're doing sine over cosine, remember your 1, 2, 3, 3, 2, 1, you have to have root 3 over 2 divided by 1/2. Then they cancel, and you end up with the root 3. So it gets a little more challenging, a little more to remember. And then the same thing when we get here, tan of 45, quadrant 1, it's positive. And look, tan of 45 is 1, you're done. Okay? Tan of 150 is in quadrant 2. It is negative in quadrant 2. What is the reference angle? The reference angle is 30 because remember it's a distance from the x-axis. 180 minus 150 is 30 degrees. So then we have quadrant 2, it's negative. It's 30 degrees, root 3 over 3. And then tan of 180, anytime that you have a multiple of 90, 90, 180, 270, 360, just go ahead and plug it right in the calculator. Okay, if you forget about it with the unit circle, it's no big deal. Put it right in the calculator. It'll tell you 0, 1, negative 1, undefined. And there you go. Tan of 180 is 0. Okay, so the tan of 180 is just 0. It's not on a quadrant because it's right on a line. Yeah, it could be undefined. That could also happen. State the values of sine and cosine of this angle. So we're talking about a 90-degree angle. And we want sine, cosine, and tangent. So again, just go to your calculator. Trig, sine of 90. Enter is 1. Trig, cosine of 90 is 0. Trig, tan of 90, undefined. That's it. Use your calculator. So the sine was 1, the cosine was 0, and the tan was undefined. Now, why? Okay, because if we do tan, which was sine over cosine, so sine is 1 over 0. Anytime you have 0 in the denominator, it is undefined. And then this one here, exercise 5, which of the following angles is tangent undefined? Just go to your calculator, and you're doing all tans. So what do we have? We have tan of 0. Enter. It's 0. Bring it down. Change it to 270. Enter. Undefined. There it is. Validate. Bring it down. And what do we have? 120. We have a value. And then the last one, bring it down. It is negative 180. Negative 180. Enter. 0. Okay. So tan of 120. It's either going to be the square root of 3. Yep, and there it is. Or it is root 3 over 3. And look, the square root of 3 is the 1.73. Tan of 120 is in the second quadrant. The reference angle is 60. Tan of 60 is your root 3. So what was this? Exercise 5. This answer was 2. Okay. One last thing here. Well, actually, there's 2. I hope I have the other part of it. Know the sine or cosine of an angle in the quadrant. So we have the sine is 5/3. The terminal ray lies in the second quadrant. Bow tie, here it is. Sine of theta, opposite over a hypotenuse. This is another special right triangle, 5, 12, 13. It's good to know those. I put the negative 12 in because it's in quadrant 2. Otherwise, you have to use Pythagorean theorem. So we have to determine the value of cosine. So cosine of theta is negative 12 over 13. Tan of theta, TOA, is 5 over negative 12. I don't care if you do 5 over negative 12, negative 5 over 12, negative 5 12s. They're all the same. No problem. And that's it. Now, for some reason, I don't have the exercise number 7. So you see it on your paper if cosine theta equals A, and A is greater than 0. Terminal ray lies in the fourth quadrant. Okay, so fourth quadrant. Here's your theta. Now, remember, A is also A over 1. So this is technically a unit circle because the radius is 1. Here's your A. So we'll just call this B. C squared equals A squared plus B squared. So we have to see how it's all in terms of A. We have to solve for this B. So we have A squared plus B squared equals 1. Bring the a squared over. We have b squared equals 1 minus a squared. Okay? And then, what do we have? Oh, get back, get back. All right. And if we take the square root of b squared, that gives us plus or minus the square root of 1 minus a squared. Since it's in quadrant 4, this b right here is going to be negative, so it's negative root 1 minus a squared. Now it wants you to find the tangent. So that's the side. I know it looks kind of weird, but that is just the side of this triangle in quadrant 4. So it wants the value of tangent. So tangent, remember, is TOA. So here is your reference angle right here. Okay, there's your theta. Its opposite, which is negative root 1 minus a squared, all over. There is your adjacent, which is a. And that is choice 4. Okay, and there you have it. And that's lesson 10, which is due Wednesday, as well as lesson 11. A lot going on in the next week or so. I know there's a lot of people missing, so keep up with your stuff and make sure you are keeping in mind due dates. All right, have a good day, a good evening, a good trip. All right, see you.